Viewers at home, you are welcome to my presentation on network analysis. Network analysis. In this presentation, I will examine the following. Number one, meaning of network. Definition of various terms used in network analysis, including the activity, event, domain activity, critical path, and so on. I will also examine the calculation of the critical path and the duration as well as the float. If you are just coming across this channel for the first time, or if you have not subscribed in the past, please click the red subscribe button and also turn on the notification bell icon so that you don't miss my upcoming videos. If you are a returning subscriber, I say thank you and God bless you. Network analysis. Network analysis can also be called project engineering technique. It can also be called project engineering technique. It is a technique for planning, scheduling, and controlling projects. Network analysis. Network analysis or network analysis is the technique used for planning, scheduling, and controlling projects. The techniques used for planning, scheduling, and controlling of projects is said to be the network analysis. Network analysis is an optimal way of managing a large project. It is an optimal way of managing a large project. Objectives of network analysis. The primary objective of network analysis is to ensure that projects are completed within the minimum possible time. The primary objective is to ensure that projects are completed. Projects are completed within the minimum possible time. That is the primary objective of network analysis, to ensure that projects are completed within the minimum possible time. That is the primary objective of network analysis. Before I proceed further, I would like to look at the various terminologies used in network analysis. Definition of terms. Definition of terms. Number one term I'm going to examine is activity. Activity. What do you mean by activity in the network diagram or in the network analysis? Activity are the task we want to perform. The task we want to perform is said to be an activity. I said activity are the task we want to perform. It is usually represented by an arrow line. An activity is usually represented by an arrow line. That is number one terminology. Number two is events. What do you mean by an event? An event is the start and completion of an activity. Is the start and completion of an activity is said to be an event. It's usually represented by circles called nodes. We usually represent an activities by, an event by circles, which we used to call node. This is one node, and this is another one. So this is an event, and we usually number it. Number 1, number 2. This is the start of that activity, and this is where it ends. So we call it an event. An event is the start and the completion, the start and the end, or the starting and the ending of an activity. The starting and the ending of an activity is said to be an event. Number 3, we have the dummy activity. Dummy activity. What do you mean by dummy activity? Dummy. This is an activity of a circumstance. An activity of a circumstance is said to be a dummy activity. It is to be denoted by dotted lines. We normally use a dotted line to denote dummy. It's usually denoted by dotted line. It is used to ensure that the rules for network is not violated. We normally use it to ensure that the rules for network is not violated. Let's assume this is the start of an activity, number 1. And if this is activity A, this is activity A, and this is where it stops, number 2. If you now have activity, it is wrong to have it draw this way. This one is wrong. To have an activity B draw this way is wrong. But the right way of drawing it, if you want to combine, if you want both of them to meet at a spot, this is activity number 1. If this is activity A, an event A, this is activity A, and this is where it stopped, number 2. And if you now have activity B, and this is where it stopped, number 3. Now, if these two activities, if they are to meet at a spot, remember this is number 2. If both activity A and B, if they are to meet at a point, remember this is facing this direction and this one is also facing this direction. They are facing different directions. So you can combine the two activities by introducing dummy. You use dummy to combine them. This is correct. Why this is wrong? It is wrong to draw it this way. That is dummy activity. The next term I'm going to examine is number 4, a part. What do you mean by a part in network diagram? A part of a network is a sequence of activities which will take off from the start to the end of the network. The sequence of the activity that will take off from the start to the end of the activity is said to be the part. Number 5, the critical part. Critical part is the part of the network with the longest duration. The part with the longest duration is said to be the critical part. Number 6, we have the critical activities. Critical activities. Critical activities are the activities on a critical path. Activities on a critical path is said to be the critical activity. So we want to consider the drawing of a network. Drawing of a network. I'm going to take work example to illustrate how to draw a network diagram. But I will advise that when you are drawing a network, you first of all use your pencil, because there is a tendency for you to erase what you have drawn. So because you won't know specifically how the network is going to be when you are drawing it. It is the drawing that will depict the direction the network diagram will face. So that is why you first of all use your pencil before you trace it with your biro. So take note of that. So now we want to solve work examples. Example 1. The activity involved in a project are as shown below. You have the activity. These are the activity A, B, C, D, and E and F. Then we have preceding activity name, B, C, A, and E. You have to draw the activity on the arrow network diagram for the project. This is the question. Now, preceding activity means an activity that will stand as an offshoot to the main activity. Now, this is nothing. There is nothing here, and there is nothing here. That means both A and B are preceded with nothing. Now let's draw that. This is nothing. That's nothing. We are going to denote it by activity 0. Now this is event A, and this is also event B. A, this is where it stopped. Let's have that as 2. Then event B also stopped. Let's have it as number 3. This is activity. This is activity A, and this is activity B. So we have this as 2 and this as 3. Now we have from B we have C. B is an offshoot of C. That means from B, C will come up. Now, where do we have B? This is B. From that activity, then we have C. This is C now. Let's have this as number 4. Then from C, then D comes up. That means C is an offshoot of activity D. So now from C we have D. Now where is our C? This is C. This is C. Then we have D coming up from that. That is number 5. D is coming up from there. Then from A, E comes up. That means A is an offshoot of activity E. Now where is our A? This is A. Now E comes up from there. E. Then let's have this to be number 6, since the last number was number 5. From E we have F coming up. This is E. From E, F comes up. Now we want to draw F now. This is where this number stopped. That means you can draw F to go and meet that here. But it is not ideal to have this last point as number 5 and then have this as number 6. So it is better you put this as number 5 and then the last point as number 6. This is the network diagram. This is how that network will be drawn. So that is the solution to example 1. Example 2. The following activities with their durations are necessary to complete a project. You are given activity A, B, C, D, E, F, G, and H. You are given the preceding activity. Remember I told you that the preceding activity serves as an offshoot to the main activity. You have name A, B, and C, B, D, D, E, and F. Then you are equally given their durations in weeks. 4 weeks, 6 weeks, 3 weeks, 5 weeks, 7 weeks, 1 week, 4 weeks, and 6 weeks. A. Draw the AOA network diagram for the project. B. Identify all the paths and calculate the duration for each part. C. Identify the critical path and the critical activities. That is the question. Now let's have the solution. Solution. The first thing, you have to identify the offshoot. The first activity is activity A. The offshoot of activity A is nothing, and our nothing we used to have it to be 0. Now event O 0. Then we have A, activity A. This is number 1. A is preceded by nothing and the duration is 4 weeks. Now let's put that duration 4 weeks. Then A is an offshoot to activity B and C. B and C. A, activity A is an offshoot to activity B and C. Now from A, now we have both B, this is number 2, this is B, and C, number 3. And what is their duration? 6 weeks and 3 weeks for B and C respectively. 6 weeks and 3 weeks. Then the next one is activity D. But B and C have to meet at a point. From the point of intersection of B and C, then you now have D coming out from there. So, but if you look at B, activity B and activity C, they didn't meet at a point. So to join the two activities, you have to draw the dummy. The dummy activity will combine the two. The dummy will combine the two. So this is dummy. And at the dummy activity, the duration is usually 0. From the point of intersection of both B and C, D comes out from there. Now let's have our activity D. Now D. This is activity D. The last activity was number 3, so this will be 4. And the duration is 1 week. Duration is 5 weeks. 5 weeks. That is D. From activity B, then you have E coming up. So that means B is an offshoot of activity E. Now, where is our B? This is B. So you have E now coming out from there. So E. And this is number 4, so this will be number 5. So the duration of activity E is 7 weeks. 7 weeks. Then from activity D, you have both F and G coming out. That means D is an offshoot of F and G. Now where is D? This is activity D. This is D. So we now have F and G. This is F and this is G. Number 6 and number 7. And their respective duration. F, we have 1 week. G, 4 weeks. 1 week and 4 weeks. Now, with what I am seeing here, E and F have to meet at a point. Now, let's see if both can meet. E and F. This is E and this is F. The two have to meet at a point. Now, let's redraw that. So that is why I said you should use pencil. The two will not meet at a common point. The two activities meet at a common point. So this is E. And the duration of activity E is 7 weeks. So now, better still, this will be number 5. If this is number 5 now, that means this cannot be 7. This will be 6. Now, no, this is activity E and this is activity F. Duration of activity F is 1 week. Duration of activity F is 1 week. That of E is 7 weeks. Now, we have drawn F. We have equally draw activity G. You know, this is our activity G. Let me redraw it properly. This is activity G. And the duration of activity G is going to be 4 weeks. Now, from the point of intersection of E and F, we now have activity H draw. Where is the point of intersection of E and F? This is activity E. And this is activity F. Both meet at 5. Then you now have H draw. You can draw H to meet G. This is H. H. And the duration of that is 6 weeks. 6 weeks. So this is the network diagram. We have, this will now be number 6. This is number 6. Number 5. This is 0. This is 1, 2, 3, 4, 5, and 6. Having completed the network, we have to draw the AOA network diagram for the project. So we've done with A now. B. Identify all the paths and calculate the duration for each path. B now. You have to calculate the paths and their durations. Paths and their durations. Now, look at your network diagram. One path, you can start from A. You journey from A, you take this direction to B. From B, you go like this, you get to E. From E, you travel like this, you get to H. That means we have A to B, B to E, E to H. A to B, B to E, and E to H. And what is the duration? Duration of A is 4 weeks. That of B, 6 weeks. That of A, 4 weeks. Plus duration of B, 6 weeks. Plus duration of E. That of E is 7 weeks. Plus that of H, 6 weeks. So that H is where the journey will end. So now let's sum up the duration. 4 plus 6, 10. 10 plus 7, 17. Let's sum up the duration. 4 plus 6, 10. 10 plus 7, 17. 17 plus 6, that is 23 weeks. 23 weeks. That is for the first part. You can as well travel from A. You get to B. From B to Domi, that is, you travel like this. You go this way. When you get here, you travel like this. Then when you get here, you also travel like this. You can travel back like this, then to H. That means you are starting from A to B. So we have A to B, B to, when you get to this place, you branch this way. That means you travel through Dummy. From Dummy to D. To D. From D, when you get here, you travel through F. From F to H, and that is where the journey ends. To H. And what is their duration? A is 4 weeks, B is 6 weeks. A 4 plus B 6, then plus dummy. Remember dummy, I told you that will be denoted by 0. Then plus D, and our D, the duration of D is 5 weeks. 5 weeks plus that of F. Duration of F is 1 week plus that of H. The duration of H is 6 weeks. And when you sum it up, when you add it, 4 plus 6, 10. 10 plus 5, that is 15. 15 plus 1, that is 16. 16 plus 6, that is 22 weeks. Then you can as well travel like this from A to B, from B to Domin as well, from Domin to D, from D to G, and that is where the journey will end. A to B, B to A to B, B to dummy, B to dummy, dummy to D, dummy to D, D to G, D to G, and that is where the journey ends. The duration of that, A is 4 weeks, B is 6 weeks, dummy is 0, and D, the duration of D is 5 weeks. 5 weeks plus duration of G, that of G is 4 weeks. Now let's sum it up. 4 plus 6, 4 plus 6, 10, plus 5, plus 0, that is 10. 10 plus 5, 15. 15 plus 4, that is 19 weeks. Now, you could as well start your journey from A and travel through this route, A to C. C to D, D to F, and F to H. So now let's have that. A to C, C to D, D to F, F to H. Now, what is the duration? A, 4 weeks plus C, 3 weeks plus D, 5 weeks plus F, 1 week plus H. H is 6 weeks. If you sum it up, so let's sum it up. 4 plus 3, that is 7. 7 plus 5, 12. 12 plus 1, 13. 13 plus 6, that is 19 weeks. So you could as well go this way. A to C, from C to D, and from D to G. A to C, A to C, from C to D, and from D to G. And what is the duration? That of A is 4 weeks plus that of C, 3 weeks plus that of D, 5 weeks plus G, G is 4 weeks. Now let's sum it up. 4 plus 3, that is 7. 7 plus 5, that is 12. 12 plus 4, that is 16 weeks. Remember, I've told you that the critical part, I said, is the part with the longest duration. Now back to the question. Identify all the parts and calculate the duration for each part. That has been answered. The parts have been calculated. These are the parts. These are the various parts, and these are their durations. Now, C. Identify the critical part and the critical activities. So, critical part now, C. Critical part. Remember, I told you that I said the critical part is the part with the longest durations. Now, let's check our durations. We have 23, 23 weeks, 22 weeks, 19 weeks, 19 weeks, and 16 weeks. The longest duration is 23 weeks. So these are the critical part. A, B, E, H. Critical part, we have A, B, E, and H. And the duration is 23 weeks. The critical part is 23 weeks. Having calculated the critical part, having calculated the critical part, I've told you that the critical part, I said, is the part with the longest duration. And you also have to identify the critical activity. This part, the critical activities are A, B, E, and H. The part we took, A to B, B to E, and E to H, that is the critical part. And the critical activity are A, B, E, and H. Now, I've told you that the duration is 23 weeks. So that is the answer. This is the end of part 1 of my presentation on network analysis. In part 2, I will examine the determination of float, and the calculation of the earliest start time and latest start time. This will be examined in part 2. Please don't forget to like, share and subscribe. Thanks for watching zica.